Hello everyone, this is Ms. LJ. Today we'll continue with part 2, data analysis on IBDP Physics IA report writing. Let's say you have completed your background introductions and methodologies, and then now you move on to do your experiment, and then in your report you started to record your data and then doing the data analysis, right? So to include the raw data, you need to design a table to organize all the data, right? If we look at the example over here, this is a very organized way that he wanted to investigate the relationship between V and S, which is the height over here. Well, there are some inconsistency over here. You should use the same symbol, right? So over here, you should use the H to represent the height. So this is something that might affect. But other than that, this is a very good example for organization of your organize your raw data. So it includes everything. So another thing I wanted to emphasize here is all of the relevant raw data. As we know, for your raw data, you might have quantitative, right? And you might have qualitative. So by mean all of your data means you need to include all of quantitative or qualitative data. So quantitative is all those numbers, qualitative is some phenomena, observation that you might have noticed. You'd also need to include it. This is kind of easy to do. You just follow the criteria. Okay, and then number 2, after you record all of your data, you are going to show the processing of your data. So as we can see, again, using this example over here, V is the one that you need to calculate, right? You cannot measure V directly. You calculate V by using the H. So there is a sample calculation. If there's a calculation involved, then you need to show the sample of the calculation over here. Calculation of the terminal velocity of the ink and its uncertainty. Okay, so you see he used the first set of data as example to get a value of V. Okay, so you show the sample calculations as well as its uncertainty. And as we know, in your original raw data, you have uncertainty, right? Then V is calculated. So we can see here, H has uncertainty, right? And V is calculated through this equation. So V will also have uncertainty, or the uncertainty of V is even bigger because it will be accumulated based on the raw data. So we talk about how to propagate the uncertainty when we're talking about the first unit about measurements. Okay, and then again here, where did you get this uncertainty? You also need to show it after that, calculation and its uncertainty. Okay, uncertainty, and show the process. And again, just use one sample. Now after you have data processing, and then the next one will be you present your data on the graph, right? So data is present. So the requirement should be in suitable graph with titles, labels, error bar, and best fit line. So we were going to look at, okay, this is label correctly. Okay, there's no uncertainty label here. There is no name over here. What is H exactly, right? Okay, this unit over here, Again, on the y-axis is the same. What is this v? Is this velocity, initial or final velocity, right? Or terminal velocity. So by this example, the v over here means terminal velocity, okay? And then there's no uncertainty in v. What is this graph about? V square and h, okay? Not v and h, it's about v square and h. So that means by using a suitable graph here, okay? So if you were choosing v and h, and you will not get a linear function, okay? But of course you could do that. You could draw a v and h graph, and then you will find out that there might be quadratic function, okay? So there might be a quadratic function as v getting higher and h getting higher. And now if you have this type of graph, then you could use some mathematical knowledge, okay? So to change it into h and v squared to get a linear function, and we call this linearization. And we were going to talk about why it is important to get a linear function later on, okay? So this is a part that you need to do if it is not linear. So presentation of the data. Now, by far, it's quite simple, okay? You just make sure that you include everything you have. If not, you just make a little bit change. Now, what we are going to talk about next is this is actually more challenge part, or more important part is after that you have to do some statistic analysis, okay? So you see this part is about data analysis. So all the things that you did before, it's not really analysis, it's just some calculation and presentation, right? Now, statistic analysis is that you need to apply your critical thinkings and some statistic terms and analysis to analyze your data and make connections between your data and the conclusion. And that's the most important part in your data analysis. What kind of analysis that you could do, it really depends on the types of the experiment you have done, but usually there's some essential analysis that you need to have. The first one would be uncertainty of the equation. What does that mean? We were taking the same example as we just talked about over here. So after you have the graph, you all have a best fit line, right? Have a best fit line. So this best fit line will have a equation, correct? And this equation is shown over here. Now this equation is kind of like your conclusion, correct? Because you, in your investigation, you wanted to know how H and V are related, right? So see, this equation has given you the relationship, the quantitative relationship between your H and your V. Y is V squared, right? X is H. So if we rewrite this equation, it would be V squared equal 18.49x. Sorry. Now X is H, right? So H and plus 0. All right. So this is kind of like your conclusion. Now, whether your conclusion is reliable or not, this is the part that you need to show your reader and examiner, right? But how do you know your conclusion is reliable, is accurate? Now you have to calculate the uncertainty, right? You have to calculate the uncertainty of your conclusion. So if your uncertainty is very low, okay, so you got the reliable conclusion. If your uncertainty is, if you have a huge uncertainty, right, and that means your conclusion is not reliable. You have to calculate the uncertainty of your conclusion. Now, the uncertainty of your conclusion is actually the uncertainty of this best fit line, right? Because the conclusion, the equation is the best fit line of equation. So you got different best fit line, you will got different equation. So if your best fit line is a straight line, and you believe this is the one that best fit, but it will be fluctuate between minimum. I'm going to use the yellow color. Okay, so it will be fluctuate between the minimum and the maximum, right? So that means you need to calculate. So the best fit line has a gradient k, so you need to calculate the uncertainty of the k. Now so this one over here, and you are going to use k maximum, right, minus k minimum divided by 2 as the uncertainty of your k, which indicate the uncertainty of your conclusion, okay, of your conclusion. So your final conclusion would be you got the equation, right, and this would be your equation. I'm use red color. This is your equation, and with your k equal to 18.496, but with the uncertainty of k, right? So this uncertainty shows how reliable of your conclusion is. Now, how did you get k max? Is the gradient of the maximum line, and k minimum is the gradient of this one. Okay, gradient of this one, and that's why usually you need to show when you present your data, you need to have 3 lines. Okay, if there's no 3 lines, there's only one best fit line, then you are definitely not going to get a good mark on your data analysis or conclusion. Okay, because this part is very important because it connects your data to your conclusion, and some of the students was doing that in the conclusion part, and we will talk about later as well, and that's also fine as long as you include this in your report. Further discussion on k, you can even calculate the percentage of k, right? So this would be your percentage uncertainty. Percentage uncertainty. The percentage uncertainty of your conclusion is a very, very important value to talk about the reliability, okay? The reliability of your conclusion. So that's uncertainty of the equation. Correlation is also important because correlation indicate that how the two variable is related. If they are closely, it's a value between -1 and 1. And once you have your Excel graph, you can see over here there is a correlation. I'm highlighted using the blue color. Okay, correlation is showing up, and this shows a very high correlation, indicate that H and V square are closely related. Okay, and that's another reference that you can use to discuss and to analyze your data. Okay, Of course, other than that, you could also talk about intercept of the graph, right? For example, if your again, this function is proportional, then the best fit should passing through the original point, okay? But as you can see, there is a slightly deviation from the original point, and there's an intercept, right? If there's an intercept, what does this intercept means? How can you avoid that? And that's something also you could analysis in the data analysis part. The example over here, and it's the IA. And then I'm going to show you the example where the students get the mark. See, this is his graph, his tables graph. And then over here, it's the analysis of his data. And you see the highlight one is where he get the mark, okay? Is where he get the mark. So here he talk about the relationship, right? But here he does not, but here he talk about R value, which is correlation, right? And between this and over here, again, he talk about is the best fit line is extremely reliable as suggested by the R value. So talk about correlation over here, and there's only a very small variation caused by systematic or random error. Okay, that's data analysis. And then again, he didn't draw the graph, but in the descriptions, he described, I will be using linearization to create a line from which the uncertainty can be extracted, right? In order to linearize the function, okay, natural logarithms will be used. Now, that's data analysis is pretty much, but all things or all kind of elements that you could do in your data analysis. Of course, sometimes you could also talk about the standard deviation of the data. Well, this is something like you don't have to do, but if you think this reference number is important, okay, then you also can talk about standard deviation and so on. It really depends on what kind of experiment you are doing. So make a quick summary on the data analysis. It's pretty much talking about something you need to pay attention when you recall your raw data, right? Record. And when you process your raw data, and when you present your raw data, and then when you analysis your data. Okay, so 4 keywords: recall, okay, recall and process, present, and analysis. Now, another part which is added by the new updated, by the updated syllabus on 2025 is communication. Okay, so communication is another criteria which was included in data analysis. So that means when you were working on this part, you pay special attention on your communication. Okay, it's because a lot of students have very, very disorganized explanations when talking about data, how to deal with the data. And that's why communication is important here. So after you have complete, just use this checklist to check whether there is any omissions, right? Where there is any inaccuracy, inconsistency, like make sure that you use the same terms, same symbol to represent the same quantity, right? Same decimal places, same significant figure. So make it consistent, okay, in the entire report, and then try to include everything that is important. There is no omissions, and then description and appropriate use of the academic terms. Okay, make sure if you know this is terminal speed, then use terminal speed instead of speed or instead of final speed. Final speed is different, right? Final velocity is different with terminal velocity, right? Just an example to show that you need to use academic term, okay? Appropriate use of academic term. And if you have include everything, all of that, everything in this checklist, then it should be fine, all right? I hope this video is helpful for you to write the data analysis, and I'm going to see you on next part in next video.